So on this next video we're going to look into configuring one of the new Siemens flow meters. In this case it's the FCT030, but it could be the ultrasonic version, which has a USB port on the front, and it's Modbus over USB. No special drivers are required, so you just need to plug this into your PC and make a note of the COM port. So I have a project already open here, which is a Modbus project. I just want to show you how we can check that. There's no software associated with setting this up, so if you go to your device integration manager, and it's normally under COM ports, and we can see there COM port 6. So if I unplug this, check to see if there's anything on the COM ports has disappeared, and then replug the device back in just to make sure the Windows not doing anything stupid. So there we have COM port 6. So in my project I have a Modbus network. If I right click that, first thing you have to do under here is tell it it's Modbus serial, which you have, and then the COM port is hidden. So if you click on the computer name you'll see the COM port settings. If we go to object properties on that, and then communication. So we have to make sure first of all we've got the right COM port set, and that the communication transmission rate and parity are set to match the instrument. So the FCT030 will work at this high speed and the parity is even. Once we've got that all up and running, we can then right click, open the object, which you already have, and you can see here the parameter list, which for a Coriolis meter can be quite daunting at first glance. So anything in grey is read only, anything in white I can edit. So this particular unit is communicating via Profibus DP, so I could use PDM on Profibus DP, but for this exercise I'm just showing you what it looks like when we're connecting it to the mini USB, which we refer to as the service port. The first thing we need to do is put the security in before we can do anything. It's set to user, but I want to show you some of the advanced features, so I'm going to put in the expert code. Okay, so the level has successfully changed. So out of the box for a Profibus DP meter there really isn't that much to set. Your units might be a prime example, but if we go to the quick start wizard we can work through these. So this information is purely text, but the tag is really important because that will be pulled through for the rest of the project on the Profibus DP side. Some instructions on how to install it for liquid and gas applications. So you can see there gas. On a Coriolis meter it needs to be upside down to let the condensation drain away from the measuring tubes. We have some wiring diagrams if you've got a remote mount. If you've got the flow meter installed the wrong way around you can change the direction. If you want to speed it up or match your pump characteristics then we can, and we want this to be with no damping. It gives me a summary of my parameters, and then I can apply and transfer those to the device. Save. So that's the setting up of the device. So as you can see, I can see my process values live. My density is a bit low, but this is water mixed with a small amount of vodka. Let's see my mass flow raw and trend these. This is part of my batching rig. So if I speed this up, you should see these. You can automatically adjust your scale here in kilograms per second, and I can get multiple trends up on one screen. Okay, so it's always advisable checking the quality of your zero. And have a look at some of the other settings that are quite nice. The flow meter has an audit trail function, so has a full diagnostic log. So on the Coriolis meter we have a SD card that logs all of the faults. You can look at them via the display on the Coriolis meter, or you can bring them back into PDM, and this will read the diagnostic menu. So this type of information is ideal when you've got those intermittent faults that happen when your back is turned. So we've got a full trace. We can also under here see what parameters have been changed. It will time and date stamp the parameters that have been changed. Ideal if you've got a SIL application. We can simulate any of the process values and alarms, and we can perform firmware updates from here as well. The firmware is stored on the SD card. Again, you can do it via the keypad, or you can do it from PDM. If we have a look under maintenance, because we put the expert code in, we'll have spare part replacement. And because of the modular design, you may be replacing individual PCBs. And you put your new part in, you come to this wizard and you click on the part that you've replaced, and it will resynchronize the whole system, copying all of the serial numbers, parameters to the part that you've replaced. So that makes replacing your spare parts nice and easy. Again, you can do that via the keypad, but it's much more simple doing it via PDM, because you get an actual picture of the part that you're replacing rather than just a text description. On the diagnostics, we have alarms. So there's nothing wrong with this meter at the minute. We can have a look at each individual alarm, and this is just showing you really the ridiculous amount of self-checks that these new instruments carry out. If we go back to diagnostics, we might want to see what's actually happening with the pickups. So we have 2 coil pickups and 1 driver current on these flow meters, and here we can see these values are all in millivolts. Have the driver frequency, and again we can trend these parameters to see how it's performing. Because it's like a bit of a closed loop system, ideally you don't want to see too much happening here. So let's see if we can see what's happening. So during this period, I can see that my driver has worked a little bit harder, and my pickups have dropped and gone back, and that is most likely going to be because of air in the system. Now I'll just do a couple more batches to see how bad that air is, and whether it's getting pushed out. So if we look at the trend now, I've done a few batches, so I'm only doing 34 gram batches, which is the equivalent to a shot, so they're very, very small batches, and I've only just put the liquid in, but you can see here if we make a reference to our previous one, our pickups are now reacting a lot better because we've pushed the air out of the system. So this diagnostic information is really invaluable. So we'll just do one more and see how I can see there's a little bit of a blip on the driver current, which is what we would expect because it's working harder because it's flowing. The good news is now the pickups are reacting the way they should, so we've pushed the air out of the system. So that's a very good live demo between the two trends. So once you've done that, you've set up the meter. Once you're happy with the data that you're getting has got no air in, so we've already looked at that from the trends, then you can proceed with a zero calibration. And again, there's a wizard for that. So now I'm happy that I've pushed the air out. We're going to do an auto zero. We could do a manual. It's going to be for 30 seconds, and I'm going to perform that calibration now. So I've got a shift on my zero, small shift. There are some instructions here. If you were to see my install, I have got a valve after, and I have got a manual valve before, but I didn't shut that because it's being pumped, and the pump's got a non-return valve in. So it's a very small system, so I've managed to trap that in there. There are some instructions here, but really the message is if you're doing a zero calibration, don't rush and do it. Doesn't need doing all the time, but 100% sure that you've got no air in the system and that you've trapped your operating pressure in there. So a Coriolis meter on a liquid application needs 200 millibar back pressure. If you haven't got that, you're not zeroing it at its optimum back pressure, and you're just going to put a bad zero into the system, and it will constantly drift as well. So we've finished that. We can click save, and if we want to, we can export those parameters. I'll put some on my desktop for now. So if I need to generate a report for somebody else to look at, I don't need my documents because there's none on there. I can export those parameters. This is the parameters that are on the screen at this precise moment in time, and the diagnostics that you had the last time you refresh your diagnostics. And so if I double click that, because I've got the PDM export file, I can see all of my parameters, and I can provide a nice report for somebody of what I've done on site. Also see here my diagnostic data. So that concludes the video looking into the service port on a Coriolis meter, which is Modbus point-to-point configuration. Thanks for listening.